And then the matrix was invented, right? Remember that? Everyone got out of that. Thank God we got out of that, right? No, but seriously, like the data just started to sprawl. It became very difficult for us to manage things like log files, metrics, and capturing all that information, right? So, all right, AJ, what's the point in all this? Where are you going? And the reason I mention this is these are the things that we do at Elastic every day is collect data, put things into a perspective that engineers can use to make better decisions about how much more servers they need to build, what's going on with the applications in their environment, and a concept we call observability. We won't talk about that tonight, obviously. But what we're going to cover is running Kubernetes on the Elastic Stack, or I'm sorry, the Elastic Stack on Kubernetes. So we run our stack, which collects metrics, logs, and telemetry on your apps, and we can look at that in a real-time fashion in apps like Kibana or front end. So today we're going to run that stack. We'll show a demo a little bit later on, but we want to kind of walk through the journey of how we got there and why we're there. All right, so just to take our story a little bit further, you know, we talked about the explosiveness of going from a single monolithic piece of hardware to a distributed computing platform. It's gotten even, I would say, worse, right? So we've kind of gone further along. We virtualized those distributed machines. So now what you thought was 100 machines could be thousands of machines, right? And then we took it a little bit further and said, well, now that we have these VMs, let's carve those up a little bit more. Let's put containers inside them, right? Let's just make it really difficult for the operations teams to find the problems, okay? So we're trying to solve that in a number of different ways. And that kind of splitting out has happened both in the hardware space, but also in the software as well. And you're seeing applications going from large monolithic web application archives, wars, jars, enterprise archive files, from Java, put on, big distributions or installations of WebSphere, to splitting it onto microservices at the other end of the spectrum, where there's a discrete piece of work that's being done, an interest calculation, decrementing or incrementing an inventory. Those types of things are being done in very small scale. So where does Elasticsearch come in all this, and what is the Elasticsearch? So quick show of hands, who's used Elk before? All right, so I'm not in a room full of strangers, so we can probably fast. So Alex, this is going to be a 15-minute presentation, okay? All right. So for the 2 or 3 people that aren't in the room, and those that may be looking at the recording, please bear with me. So we'll go through this rather quickly. So from top to the bottom of the stack is Kibana. That's our visualization layer. It's where you can actually create, obviously, visualizations, but also manage the stack. So we can do things like select a bunch of indexes and delete them, create ILM policies around those indexes, move them from hot to warm to cold, and do a lot of management in that UI. There's also a lot of other visualization technologies we won't cover tonight, but there's a lot of them, and every release there's more and more new things in the Kibana. All right, so at the heart of our stack is Elasticsearch. It's this scalable storage, persistence, and analytics layer for everything we do around Elastic, right? So what's unique about it is that, and we'll show this as an example tonight, like I could stand up a 3-node cluster, I could throw an index out there, and if I add another node to the cluster, if there's remaining shards, it automatically moves it to another Elasticsearch node without having to configure that. Like in days of old, if you wanted to stand up something that did that, you'd have to script it all out, you'd have to plan for it, you'd have to take an outage, you'd have to move this volume from one server to another. There was a lot of work that happened there that's being handled in Elasticsearch underneath the scenes. All right, our ingest layer is at the bottom, Beats and Logstash. Who here has used Logstash before? Who here has a question about Logstash and wants to tackle me after this and ask me questions for about an hour? There's one guy. There's one guy. There's always one guy. I knew it. I knew it. Okay. It's $60 an hour, and I do take Venmo. Okay. I'm kidding. I'm kidding. All right. So our ingestion technology is it's kind of twofold, right? So we've got these beats, which are lightweight shippers written in Go that you can deploy on your servers that collect information. We have 7 of them today. I won't talk too much about what they are, but they will collect information and send them to Elasticsearch directly. And then Logstash is part of our ingest. It has like 200 input plugins, so you can grab things from database tables, queues. You can grab it from Elasticsearch too as an input and transform it. So people use Logstash to do transformations. All right. So that's the platform. And we've been a platform for a long time. We've been the Elk stack. We got an acronym, so we're legit, right? We're like LAMP, but we have Elk. So we've been thought about that for the longest time, and people have been using us. But now we're kind of pivoting as a company, as Elastic, and saying we need to build solutions. We need to build things on top of Elk, right? So that people can start getting value out of it, out of the box. And that's kind of where some of these solutions come in. I'm going to I'll throw a warning flag up here, community warning flag. I will talk about commercial features for like 15 to 20 seconds. And then beyond that, we'll get out of selling mode, okay? But, so stack solutions. So we have observability, security, and search. These are some of these aspects are part of the basic stack, which you get for free. And by the way, does anybody know what the basic stack, or is anybody using the basic stack today? Got a couple people, right? How many are using open source? A couple using open source. Any commercial consumers? I've got a couple of them here. Okay, great. So we've had these solutions, and what that means is that we've started down this path of creating an Elastic Common schema where all of our ingest technologies, and there is a schema, so you could apply your own ingest to it as well. When it's fed to Elasticsearch, these solutions come to life: logging UI, infrastructure UI. So let's kind of walk through this real quick. This is a quick view of a Kubernetes view in our infrastructure UI. So if you've got metric beats and file beats in your Kubernetes environment as a stateless application, and these are container and Kubernetes aware, they'll start picking up logs from your pods and sending them to Elasticsearch. And then you can start drilling in on this little video here, shows you what some of those things can do. So again, if you've got a Kubernetes environment and you want to look at this kind of view and drill into what's the health of my Kubernetes pods, what's going on in my environment, we can see this at scale. Next part of this, as far as solutions, is logging. I kind of joked about the matrix earlier, but how many people have had a tail minus F running today? Oh, like everybody, right? Okay. How many have had like 12 tail minus Fs on 4 screens running at any point in their career? A couple of them, right? So you take all of that tail minus F and you consolidate it down using file beats. So what you're really doing is going out to a bunch of servers and saying, I need to see the logs, and I might pipe a grep to it or do some uniqueness to get to that tail minus F. But I want to search for something specific, right? So what we've done with the logging UI is we've said, yeah, we get it, tail minus F. Let's stream it, and then let's do a search at the top. Let's do our filter up here. And we'll also kind of give you pointers on what kind of things you can search on if we can, right? So that's a logging solution. And then there's APM. It's another part of our solution stack, is being able to take telemetry, traces from your code, and stick that into a curated UI so that you can start finding out what's going on with the app. That APM prior to joining Elastic was a huge part of my life. It showed me that nothing was wrong with my application, of course, being on the dev side. Everything was wrong with the infrastructure, but it's a really good tool to share amongst all the teams and say, hey, we've got a problem here. Let's go look at everything. Let's go look at logs and metrics and look at traces. So those are some of our solutions. Any questions on that? Yeah, good question. So the question was, are they separate installed things or plugins or applications? So Metric Beats will collect, and there's a bunch of modules for a couple of these. Metric Beats will collect basically statistics from applications, right? Telemetry, CPU usage, that kind of stuff, right? And sends that to Elastic. So once you start doing that, if you have Kibana plugged into Elasticsearch, that infra UI, this one back here on the screen here, it comes to life. There's nothing you need to do. Metric Beats will already, this will already know that Metric Beats is populating stuff. And if it's Elastic Common Schema, which all of the beats are now, this thing comes to life. And the same thing holds true with the logs UI. You can start searching on that too, because we're going to start sending things based on the Elastic Common Schema. So really all you need to do is install the beat, install Elasticsearch, get Kibana going, and you're off to the races with that UI. And it is basic. So we've kind of stepped away from the whole commercial side of the discussion, right? It's part of the basic stack, which is free. All right. So any of the questions. A little bit about deployments and what the history at Elastic and what we've been doing, right? So everyone's had the Elk stack. They've downloaded the zip file from the website and unzipped it, got it running, and said, this is great. Let's get the RPMs on all the servers and build this massive cluster. And we saw the potential for this scaling, a community of users that want to use this. And so we joined forces with a company a number of years ago, I think it was 2015, called Found, that had a really good SaaS offering. They've been with us the whole way. So we have a public cloud offering called cloud.elastic.co. And it's got over, well, it's 3 providers, right? AWS, GCP, and Azure. It's in 17 regions, and it's been around for over 7 years. So it actually is older than, well, at least the release version of Kubernetes. So I get asked a lot, like, what is it? What is it underneath the scenes? And it's code that we wrote to orchestrate Elasticsearch. It is not Kubernetes. It's our own stuff. And so we're really kind of down this path of like, well, the community wants Kubernetes and we've got this thing that orchestrates in our cloud. We said, well, the enterprise needs something immediately. We got to get something that is a product that they can use. And that's just this kind of like, I'd say a layer over, right? Which is Elastic Cloud Enterprise. So we take all that software that runs our public cloud and we provide it to enterprises. Commercial alert here. We provide it to enterprises as a product for you to have SaaS on premise. All right. And then I still get asked the question, well, what about Kubernetes, AJ? We're a Kubernetes shop. So unless you got Kubernetes, just get out of here, right? Just don't talk to me about Elastic. But we've been thinking about this for a while. So we knew that Kubernetes was not going to go away if we ignored it. Just kidding. And we've doubled down on it. So we started down this path of recognizing that there's a need in the community, a need in technology for Kubernetes. So obviously Kubernetes was released in 2015. I think everyone here probably already knows that, right? We produced a beat 2 years later, 2 beats that were auto discovery capable and looking at like, what environment am I running in? Am I in a Docker environment? Can I talk to the Docker daemons? No. Am I in a Kubernetes environment? Can I run some kube commands? Yes. Okay, great. Now I can start doing things and I can start populating Elasticsearch, right? And then moving forward, we obviously knew that we needed to be part of the Cloud Native Foundation because almost every meeting that we go to that when people are talking about Kubernetes, they're like, are you Cloud Native? Are you Cloud Native? So yes, we're part of the Cloud Native Foundation and we've been working very hard to kind of contribute as much as we can to that. And then we also created a Helm chart, which was, obviously I'm not going to demo that tonight, but it was something we were trying to figure out how are we going to deliver Elasticsearch as a product in the Kubernetes space as something that can be maintainable. So Helm charts was something we experimented with, and I think we still have that out there documented, but I don't think we're moving very further along on that front for now. And then the operator came out, the capabilities of operator came out, and we just jumped on that and said, all right, we're going to build our own operator, and that's what we're going to see tonight. So everyone wants to see that, right? Who here, show of hands, has played with the operator for Elasticsearch? Just one. So everyone in this room is going to lose their mind when I demo this. Is that what I'm hearing? Nice. Zach, can we record this? Where is Zach? Can we record everyone losing their mind? Oh, yeah, both Zachs. We have 2 Zachs from Elastic. See, resiliency, redundancy. We have 2 Zachs. All right, before we go to that, some of the challenges we had to consider. So, we get asked, well, what are we going to have? Are we going to have Kubernetes for Elasticsearch? So it's very recent implementation for Kubernetes to handle persistence, right? So to be a company that is a persistence technology presents itself with a bit of a challenge. But obviously the latest versions have that in mind. And so we've kind of moved past that and the operator gets us there, right? How are we going to continue to have a good uptime and availability in this? A couple other things in here like security. So there was a release not too long ago where we had one feature that was introduced. One single feature. Who can tell me what that was? It was, sorry? It was security, yes. So we gave away, well, we gave away, it sounds really like we're charity here. We opened up to the community the ability to secure their Elasticsearch clusters in the basic subscription, which is free, for some native and file-based realms so that we could have security out of the box. And the reason we wanted to do that is that when we get to this part of it, deploying in Kubernetes, we need to have security handled. Because you're going to stand this cluster up and you're going to want to have node-to-node encryption. You're going to have authentication, at least at a fundamental level. And that had to be part of that solution. So it's kind of the reason why you see that one security feature release. I thought it was pretty interesting to have that kind of statistic. If you think about it, it's one feature in the stack for a particular minor. It wasn't even a major release, it was a minor for both 6.9 or 6.8 and 7.2. And just to look at the statistics on how many people downloaded it that day when they realized like security was available. Oh my gosh. So there's enterprise versions of the security that are not available in the basic, and we won't get into that. But anyways, we had security in mind. And then also some isolation in the namespaces and flexibility, right? And then obviously this is kind of not news to you, but the operator capabilities within Kubernetes gives us the ability to create some custom resource definitions. Today we have Elasticsearch, Kibana, and the APM server as those resources. I won't demo the APM part of it today, but if you see the pattern in Elasticsearch and Kibana, I think you can draw your own conclusion as to how to set APM up. So we have these controllers that will help control scaling out, scaling up, and all the things that we're going to see in the demos. And then also, a lot of times we'll get asked for best practices. Like, tell me how to build a cluster that is going to like be the best. Like, I need some help with this because what we're building is not the greatest right now. It's falling over and we're having issues with some of the configuration. So that helps us to enable best practices in building these operators for the users. Okay, one other point on this slide is it's multi-cloud capable. So if you're at Amazon or if you're Google, if you're bare metal, you'll roll your own Kubernetes that's available and works with those Kubernetes. Tonight, I was going to try and kind of get creative and have 2 cloud providers, but I'm just going to stick with Google tonight. I hope there's not a problem with that. If there is, I'm sorry. We'll stop recording. But yeah, so we can have that native Kubernetes experience. And you'll see I'm not going to be running any special commands. I'll be using the operator to get things running, but we'll basically you'll see me using, kube controller, whatever, kubectl, however you want to pronounce it. I call it K because I made an alias for it. All right. And one of the things we won't see tonight that I'll mention is something that you will be able to still do, which is be able to create hot warm architectures to do things like information lifecycle management. So you can have zones created for hot nodes and warm nodes in the configs. I'll show you kind of where that entry point is for doing that, so that you can kind of go, oh, I get it. There's a config parameter I can add to the configuration for Elasticsearch, and now it's defined as a node attribute of warm. Anybody doing hot warm with Elastic? Couple are doing hot warm. Okay. Does everyone know what hot warm is? Should I talk about that for a second? Yeah, I'm getting a nod. Okay, great. So we have an information lifecycle management capability. A lot of customers, a lot of users in the community will they'll say, I need the first week hot because it's on solid state drives. Solid state drives, I think, are still expensive, although I don't know, I could buy a terabyte for a couple $100. But anyways, that's a cost concern, right? Especially in the enterprise. Seems like the vendors up the price on enterprise solid state drives when it's literally the same thing. But so you'll put it on hot, and then you'll want to move it to warm, which could be maybe even a more dense version of a solid state drive, or maybe your hot was an NVMe drive and your warm is a solid state drive. And moving the story along, there could be a cold area where, or even a denser warm where it's just spinning hard drives that are super cheap. And that's kind of where the hot, warm, cold architecture comes in. And there is frozen. Is there anybody using frozen indices? No. Okay. All right. So frozen is just, we basically, I would say for lack of a better term, we close the index, although it's still available for searching, and we drop all the memory structures out. So, but anyways, that's ILM and hot warm architectures. You should be able to set that up within your clusters using Kubernetes, but we're not going to cover that today. All right, I'm going to jump into demos. You guys ready for demos? Yeah, ready for a demo? I don't hear anybody losing their mind right now. Maybe I got to demo something for that to happen, right? There we go. Got some whistles. Okay. I've heard of a hot mic before. I've never heard of a heavy mic. This is oh, there we go. Yeah, that's fine. All right. So the first demo we're going to do, there's 3 demos. First one is just create a cluster. Okay. What I've done is I've shortened this up. Now, I created these scripts. I didn't have someone come out and write them for me. I created these scripts myself, so I'm super proud of it. All right, but there's a series of them. I just numbered them, right? So the first one, by the way, can you guys see that okay in the back? Is that all right? We're good? Okay. A little bit more. All right, let me amp up the. It's about as large as I can make that puppy here. Let's see. How's that? Better? Okay. All right. So the first one I'm going to do is I'm going to just make sure I can connect to Google. All right. Cool. I can connect. I've got a kube command running down here below, which is just basically checking for any kind of pods that might exist. You'll see this start to change during the demo. Okay. All right. So the next thing I want to do is I want to install the Elasticsearch operator, the ECK operator. I want to show you some of these. Obviously, it's not just hidden behind a script. But what we're doing is we're applying a URL, which is our all-in-one YAML, which will contain all of the definitions, the custom resource definitions that you need for Elasticsearch, Kibana, and the APM server, right? So we'll go ahead and we'll configure that. So I'm just going to run this. You'll see at the bottom of this script, it'll run, the operator's not ready, but if I ran that last bit of the command, cat1, and just check for the stateful set to see that it's active. All right, we're ready. So we're up and running. Okay, so the operator is available. All right, so the first thing I'm going to do here is I'm going to add Elasticsearch. Again, just kind of keeping with the visibility of what it is AJ's doing up here, is we're applying this URL, which is just the definition for the Elasticsearch node. And we're going to give it a configuration. I'm going to give it a configuration of a version that is one minor less than what's available to today, 7.3.0. I'm going to give it a cluster name of cluster A. Warning for anybody who tries to get creative with the naming of these. Like I put cluster A as an uppercase when I was playing around with this. Apparently we don't like uppercase characters in this field. So, and then a count of 3. So I'm going to create 3 nodes that are master data ingest eligible. So all 3 of them can either participate in becoming a master node and then be data nodes as well, right? All right, so I'm going to go ahead and run this. Now this is for the visually challenged folks in the back. I really only want you to just see that there is some activity here, but you'll see that the 3 nodes are starting to spin up. I have 10 nodes available to me in my environment, and they're not the fastest nodes, so I've got to find some filler conversation in here and what's going on. But really what's happening is we're getting a container ready. We're spinning up Elasticsearch. You know, the JVM has to start up. So there's a little bit of an initialization time that takes place in this, right? While that's going in the background, what the next step I would run is I want to get the visualization layer up for us, Kibana, right? So let's take a look at what that looks like. So much like the Elasticsearch one, I'm doing the API version is the same. You'll notice this is beta. By the way, the Meetup notification was for alpha, and in that time that we set it up until now, we actually released the beta version of this. So we are getting closer to GA, which I think is probably a question that'll be coming up soon, right? All right, so again, I'm using the same version. I want to have 7.3.0, and I've had to specify a load balancer HTTP service so I can get to this. And we're gonna have to do something interesting on the back end to be able to see that. So anyways, I'll go ahead and run that. That's script number, what did I say, 3? All right, so we'll see down here a little bit more activity. So you see all 3 nodes are up and running, and they're ready. So that means they're accessible. And now Kibana is coming up. So while that's coming up, one of the things I need to do is I'm hopping over to this other screen because I kind of really need 3 to do some things here. The first thing I'm going to do is I'm going to start once Kibana is up and running. It's still pending, but I'm going to forward Kibana. Since I'm running it locally, I need a port forwarder so I can use my local host 5601 to get the URL up for Kibana so I can see things. So I need to give this a few seconds. It's still pending. And then the other thing I'm going to do in short order is what I'm going to do is I'm going to ask the Elastic Stack for a secret. So it's part of the security part of this. We had to generate, whenever you build a new cluster, we're generating a new password, and I have to ask for that. It's kind of interesting. We can get into the weeds on, you know, is that really secure or not? But the reality is I have to ask the cluster, hey, what's the password for Elastic? I got to get in. And it's certainly a heck of a lot more secure than it used to be, where it was Elastic. I think it was change me was the password way back in the day, our default password. Anyways, this is a more random password that's assigned to it when the containers are built. Giving them a few more seconds for that last container to start. Kibana usually takes a little bit longer, and like I said, the compute resources that I used for this are not very large. All right, so I'm going to start the forwarding. It's probably going to pause not running. What's that? Yeah, it's container creating. What I'm going to do is I'm forwarding 5601 to localhost. So I'm just kind of waiting for that container to finish creating, actually to get it running. We're almost there. When I ran through this this afternoon for like the 4th time, it was about a 16-minute demo on all the things that I want to do back to back. So this should have come up a lot faster. Let me do this. It's 88 seconds. So it's spinning up some nodes. I had 10 nodes up earlier. I assumed that they were going to stay up since I told it to stay at 10, but it didn't. All right. So I'm going to ask Elasticsearch for the secret. I'm just going to copy that because when Kibana is ready and I get the port forwarding, I'm going to need that as the password for Kibana. That's the password that's generated when the cluster is built for the first time. Okay, so Kibana is up and running. The state for that pod is showing running. I'm going to run my little forward command so I can get access to it. So now it's forwarding to localhost 5601. Where's my, so I can go to localhost 5601, oh, wait a minute, secure HTTPS. Ignore all warnings from browser. All right, I'll type in the Elastic password and we're in Kibana. So that is setting up the cluster. So that's demo number one, right? Demo number two is we're going to expand this cluster. So now we have a 3-node cluster. We want to add a little bit more. But before I get into that, what I want to do is I'm going to do a couple things. One, I'm going to open up the monitoring application in a separate tab. By the way, if you're wondering what these icons are, every Elastic employee has to memorize them. I'm kidding. So think you can pop out this bottom button and it'll show you what they are. And you could just kind of get used to them after time. And then we'll change them on you. Okay, and then so I have the monitoring one up, and then I'm going to go into Dev Tools, which is kind of like our console for Elastic. You can write queries and do all sorts of management stuff in there. So once monitoring is on, what I want to do is I want to show what happens when we add an index and we add another node, but underneath the Elasticsearch under ECK. All right, so while that's coming up, I'm going to create an index. If you can see this at all here, I'm going to create an index and I'm going to define it. It's called Kubernetes for Life. And the settings for it is that it's going to have 4 primary shards and 1 replica. So it's a total of 8 shards, right? And I only have 3 nodes. So there's going to be a node that's got an extra replica and one that has an extra primary. So I'm going to go ahead and create that. My monitoring should be up. Actually, yeah. So we look at indices. You'll see the Kubernetes for Life index has been created. If I click on it to go look at it, there's telemetry information and monitoring. This is all the cool stuff that comes with basics, so you can see exactly what's going on with an index or a node or the cluster itself. What you'll see here is I have 3 gray boxes that represent those 3 nodes I created, and then a numeric representation, whether it be primary or replica, of shards that are that index. Okay. So now that we've got it out there, let me just go ahead and I'm going to create a couple documents in the index. Just 2 documents, and I'll come back and create a 3rd later. All right, so let's get into the second demo, which is scaling this out. I don't think I need this UI for a while. Let's get this one. All right, so the next thing I want to do is add Elasticsearch nodes. So let's take a look at script number 6, which is simply the first script number 2 that we used to add the nodes, right? The first 3 nodes. But then we've added another section. And these are 2 data nodes. With these nodes, the difference is that, first of all, I've given them a name that's cluster A data. So there's going to be data nodes. There's only 2 of them. And then I've defined them as master false, which means they're not going to take part in being a master at all in this cluster, right? I can do other things like turn off ingest and have them just be pure data nodes, but I really want to add them as just data nodes in this environment. So let's run script number 6. And we should see, there we go. We got the 2 data nodes that are going to come into play. So that's cool. We can watch this. I'm sure most of this group has seen this command on their screen. It's burned in at the bottom. So I'm not going to show that. What I want to show you is just kind of a refreshing of this screen while, let's do the last 15 minutes. And we'll refresh it every, I don't know, how many seconds should I refresh it? 2? Every 2 seconds. There we go. Audience participation. Let's stop it, start it. And we'll start to see after the nodes come up, they'll join and you'll see them listed here as data nodes. And then something magical will happen. And now that I've said magical, it won't happen. Still pending. Yeah, sure. Yes. Yes, that is the master. We have indicated that this is the master for this cluster. If it were to go down, obviously there'd be an election held with the remaining nodes, and then there'll be a new master elected. And the purpose of the master node, for those I think probably don't know or do know already, it's a good refresher, is responsible for shard routing when the new node joins, making sure that they get shards, which we should see here any minute now, Kubernetes. But we'll see that in the mappings for the indexes. So when you create a new index with a new mapping, that information is kind of responsible by the master nodes of knowing what the mappings are for that index, right? How far along are we? We're in a knit. Okay. I think what's happening here is that yeah, more nodes are being spun up to handle this. More super tiny nodes. All right. Okay, one of them is running. The other one shouldn't be too far behind here. And then once they're in ready state, we should start to see them show up in this view here. There's a bunch of other views, but for me personally, I find this the most interesting when I'm just dealing with one index. Like, where are the shards? What's the allocation for this index? A lot of times what I'll see is, by the way, between 6 and 7, we went from a standard default shard count of 5 primaries in one replica to just one primary. There you go. You see it happen. One primary and one replica. So now it's kind of an interesting shift in the way we think about how to distribute the data. But in this index that I created, you notice that the 2 nodes have come online. One of the 2 nodes has come online, and it's already started to receive an allocation of these shards that are out there. So we're automatically scaling these out as the cluster is being built. We've got one more node to join us here. While that's going, I think you guys get the gist of what's going on there, that we're adding nodes on the fly. We're not having to bounce the cluster to do that. Curious, for those that are doing self-managed, how long does it take you to add a node to your cluster today? Anybody want to chime in for how many hours, or yeah, how long does it take you to add a node? No, just a regular like zip file or RPM based install and Elasticsearch. Yeah, sorry. It depends. Okay. Yeah. Hours. Yeah. Not to mention the change controls and the paperwork to get approved and all that stuff. Yeah. Okay. So I think our other, while that one's up, let's walk on. That's demo 2. We'll wait for that 5th node to show up, which should be, oh, there it is. It's already there. So we can validate this by looking. We should see 5 nodes, and all 5 nodes have gotten some shards. They're all participating in the cluster. Okay. The last piece to these demos. So we've done just a basic build of the cluster. We've done an upgrade. I'm sorry. We've done a reading ahead here. We've done an add. We've expanded. And these are the basic functionality pieces that operators need to get Elasticsearch up and running, right? And the last one is just to do an upgrade. And much like what I did before, it's a little bit of copy and paste. But if I do more on the Elasticsearch upgrade, essentially all I've done is I've taken the existing file and just changed the version number on it. What's interesting about this, do you think is it just going to go out and create this entire cluster? But it actually doesn't. The operator is intelligent enough to go, I'm going to roll through this. I'm going to go one at a time, because I don't want to have this massive amount of compute when I only need one to come in at a time. So when I run 7, upgrade Elasticsearch, and I spell it right, we're going to see one node at a time. I think when I ran this before, like one of the data nodes drops out. Yeah, there you go. It terminates. A new data node with a new version comes in, and it rolls through all the nodes in the cluster to take care of the upgrade. It depends on like how many shards you have in your if you don't have enough nodes because you've had so many shards, like that could be an issue. Space allocated could be another concern for the Kubernetes nodes that you've assigned. So there's a lot to play into that, but the automation should be there by the time we're GA. I haven't tried it in this evaluation environment in beta to shrink, but yeah, it's a key feature we have today in ECE as well as the public cloud offering. So obviously, it's got to be something we're doing here in ECK. All right, so I'm only gonna roll through a couple of these to see that in Kibana you can see this. And then it's the same thing you do with Kibana. We just change the version number, roll it out to the operator, apply it, and it will upgrade that version. See, we already have one node missing, so we're going to start rolling through that. So those are the three pieces to this demo. Nobody lost their mind. Seriously, I should have, like, it's too close. I can't yell and have excitement when I've got the radio mic. One other thing I just want to mention here for this presentation, okay, is this. Yeah, that's it. That's the demo. That's showing upgrades and rolling through the upgrades. And by the way, I'm sorry, I should mention this. I forgot. This is one piece that it's kind of important for this, is that we're doing an upgrade right now, and I'm going to add that third document, and it still updates. I can also do a search on this, and it still updates, and I get 3 documents, right? So there's no downtime. We're continuing to ingest, we're continuing to do queries while this takes place. It's inherent in the design of the cluster and being able to come up. You had a question? When I'm doing that post? So some of the nodes are, while the migration is going on, will not be able to do any ingest. It's part of the upgrade. The operator will say, just like any other upgrade, hey, you can't ingest here, and you probably shouldn't participate in a query either. So we're going to take you out of the cluster, right? The primaries or the secondaries on the other nodes will take over for the queries for that data, and the updates will just take care of themselves when the other nodes have balanced out. Does that make sense? All right, so just the point there is, like, we can update and we can scale, we can do updates, and we can do queries on the data as the environment's changing. And the last thing I wanted to mention is everything I showed here, I put out in my personal repo, but here's a link to it. So if you wanted to grab these scripts to play around with it and didn't want to have to sit down and read the documentation, it's available. I'll give this to Alex. He can put it in the show notes for the meetup. Okay. Or you can take a screenshot, or like some are taking right there. I tried to make it simple, but then I realized at the end, it's like, wow, that's like something you got to write down. You can't remember that. But okay, that was it for this. If you see pictures being taken, I'll wait for the cameras to come down. All right, so that's it on the demo. I didn't hear anybody lose their mind, but that's okay. Maybe you're just stunned. You're like, okay, I get it. It's awesome, AJ. So I think I've got a few more minutes, right, Alex? Where are you, Alex? Yeah, I got a few more minutes. Are there any questions? And if not, we can roll into the next presenter. And I'll be here for a little while. If you just feel better not asking a question from a large group, I'll be here for a while if you want to just come up and ask me a question. So are there any questions? What's the relationship between cluster nodes and Kubernetes? Yeah, it's a great question. I had that too when I was looking at this. So the question was, like, is there a relationship between Elasticsearch nodes and Kubernetes nodes or pods? Like, how does that work? Can I have many to one, one to many? And yes, you can. There's so much in this that we're putting to the operator that I can't show all the variations. I just wanted to get the simplest part of it out here. But you can say, I want to have, let's just say I got a 4 gigabyte Kubernetes node, right? And I want to put like 2 1 gigabyte Elasticsearch nodes on there. You just have to make sure that it's going to fit. And there are parameters for those configs that I showed you. They're not in there, but like in our documentation, they give you the ability to limit the memory on the Elasticsearch node so you can get them to fit into less nodes, right? What I wound up doing was just saying, to get to my demo, how many nodes am I going to need? And I just spun up 10 nodes, right? Well, at least I tried to. Google went, shrunk it down. Alex, you had a question? That's a good question. I don't know. And I'd have to take that as a follow-up to this group if everyone's interested. I don't think it would not be open source, but I'd have to look. It's a question that I've never been asked before. So you're the first on that one, Alex. So we'll look into it. Yes.
The way that this was packaged, I know that like you went through a couple scripts, so there was some behind the scenes that I wasn't. So I realized that a lot of this was like, like Kubernetes, like stateful sets we saw, so like the system buffer or whatever. But like you install the nodes, and then did you, in those scripts, did it end up like calling the operator to say like make stateful sets? Or did the nodes like contain that? Like is that some of the magic behind like you provision specifically a cluster A node? Would I be able to like deploy stateful sets using the operator on just a regular old node?
Yeah, it's a great question. So the way I understand it, again, this is where the deep end starts. Thank you for me. Is I didn't help develop the operator. What I understand is that we've given custom resource definitions for Elasticsearch, for Kibana, and for APM, right? And in there, I believe is where the stateful set definitions are for those individual things. So I'm not sure what you would want to do beyond what I showed. Are you looking at or thinking about other technologies that you want to do that with, or?
Thinking about like how it's packaged and how it's deployed.
Yeah.
Whether that's just like you just set up nodes and then like pods came up, right? So that's like it was like a daemon set because you set up like 4 nodes, or like a stateful set 4 nodes and 4 pods. But like, if I just like set up a Kubernetes cluster without like a custom node,
Yeah.
would I still be able to do that?
So I don't read operator syntax, but what I could tell you is this: like, we go back to if we go back to looking at what I did for step 1, which is to install the ECK operator, right? We grabbed this YAML, which has all those definitions in there. But the one thing I don't know if we saw there was I can do a describe on this, and it gives you a little bit more detail on how this was configured. Does that make sense? Like, again, I don't like this is the resource definitions that are in here for these operators, right? So, and that's kind of why we kept it high level, right? Cool. So I don't know if I effectively answered, but it sounds like he's got the theory right. So, are there any other questions? Yeah, there's one in the back of the room. Yeah, so the details on that are kind of forthcoming. So it is beta, and so those things that like how do I do hot warm across nodes, across different clusters? Is that kind of where you're going, or? Yeah, that's going to be kind of out of the realm of my knowledge. My apologies for that. I can dig into it. We can certainly dig into it, right? Yeah. Ooh. Yeah. Quick, somebody give me an Ansible script, and yeah, I don't know if that's gonna. I don't think it's gonna work that way. I mean, so like, can you access Kubernetes from a Windows command line today? Do you have like a native, like I'm using the CLI today, right, for Google Cloud. Okay. So are you running the CLI for, yeah. So then you have kubectl, you have all the commands available to you in that subsystem, right? I don't know. Yeah. Yeah. Yeah, so I mean, I give it a try. Yeah, you can unplug me if you want to. Yeah, so I say give it a try and then let the group know. But I don't see any reason why what we ran tonight couldn't run. And again, that's in my repo. Give it a shot and then put it out in the group chat for the channel. I'd certainly like to know. I don't know if I'm gonna have time to set something like that up, but yeah, give it a whirl. Cool. All right. Well, I think we're getting set up for our next presenter. I want to thank everyone for your time today. Apologies for some of the questions we couldn't get answered. We'll at least try to get something back to the group. Usually make it a habit of kind of responding to the group chat with some of the stuff that we have to follow up on. So, all right. Thanks.
Cool. So we've got Brandon from Tigera coming up next to talk about running Helm v3. So we have a couple minutes to break while he sets up. So grab food or a beer. Yeah. Right.
Do that.
All right, folks. I think we're about ready to kick back off. If you want to grab a seat, guys, I think we're ready to go. All right, folks, we're going to go ahead and kick off. So we've got Brandon here from Tigera to give us a talk on using Helm v3. We can go ahead and welcome, give him a round of applause. Up. All right.
Cool. All right. All right. So, how you guys all doing? kind of wait for everybody to trickle back. I know this guy here. Glad you could make it. All right, so we're going to talk about Helm v3. There was an announcement a couple days ago too. You might have saw it, where they went into beta phase and they're saying to use it, you know, kind of the pre-production. Everybody has an open source project. They're like, use it, you know, kind of be the guinea pigs out there. I would hold off on the production part for a little bit, but definitely use it and give some feedback to the Helm folks. Just kind of getting a feel, how many people are using Helm today? Okay, cool. And are you guys using Tiller today, or are you doing Tillerless? You doing Tiller? Okay. Right, that's cool. This one better? Is this better? I don't know if this is any better. I think this is actually worse. I think.
Yeah, try that.
Okay. Sorry. That's okay. Is this a little better? You can hear better. Okay, cool. So a few Helm folks, anybody who's kind of waiting for Helm v3, maybe before going, okay, yeah, so you're using it, but you're also waiting for v3. Okay, all right. So what we're gonna do is we're gonna split this out. We're gonna do a little bit of a history of Helm. And so this talk is kind of gonna take you a little bit on a journey, right? On why we're kind of left with some of the artifacts that we have today in Tiller. There's a lot of talk about Tiller. There has been for the last couple of years, especially when security kind of, you know, people started looking at it a little bit more for production use. There are some security concerns. So we're going to go into that kind of in depth and go through the life cycle of Tiller getting installed, what's actually there, what's actually in your cluster. And to kind of go a little bit before this or whatever, I kind of failed to do this. You guys don't know me. My name is Brandon Jozsa. I'm a solutions architect at Tigera. Before that, I worked at some pretty large companies. I worked at AT&T. We ended up having a big project there. It's now called the Airship Project. I don't know if you guys are aware of that effort. So I don't know, one of the original authors of Airship. So that was kind of my brainchild, actually. So they're using that for all the 5G stuff now. And then I went to, and that kind of got pushed off, and another team started really kind of managing that, and I wanted to do it again. So I went to a company called Charter, and we ended up building out their Kubernetes platform, and that's all self-hosted and things like that. So I know how to build platforms really well. We architected some really cool stuff at AT&T. So if you have any questions, I'm here to talk about that. So anyways, in both of those platforms though, Helm was kind of a central key piece. But I think if you're gonna do that, you should really understand the security aspects of Helm, because there's some ugly things under the covers or whatever that we'll talk about. So with that, the overview, we'll do a history of Helm. And again, it's kind of a story on why we have these artifacts there today. We'll cover the V2 model. We'll go into Tiller and the life cycle of Tiller getting installed and so forth. And then we'll get into changes in V3, right? So a lot of the move to V3 is around changing the security aspects, right? The architecture of how Helm gets deployed, how things get rendered. I think there were some learning experiences that the Helm team had. So like, for instance, we'll cover what extensions would be, how you would, there's Lua, there's a whole lot of options. So, and this is all from the pain points of V2, and so we'll talk about that. But the three aspects that we'll focus on is security improvements, operations improvements, developer improvements. And then we'll do some demonstrations to kind of talk about these things. So I think we've got maybe about 40 minutes, let you guys kind of lead it. So it's real open forum though. So if you have something, just shout it out. That's totally fine. Anybody can ask anything. So the target audience, I always like to set the target audience at the very beginning of the talks too. So that way you know where you might be interested in. General information for folks that may be new to Helm, maybe not using Helm. We'll talk about general, Helm-ish things, right? For intermediate users, we're going to talk about improving the security model from V2 to V3. And then for advanced workflows, if we have enough time for it, I'll go really, really in depth on something I'm passionate about, which is a library chart. We used it at AT&T. It was the lifeblood of that whole project. So if you're not familiar with Airship, it's like taking all the OpenStack components. It's all containerized. It's all being deployed using Helm in Kubernetes. So basically you just stick in a thumb drive into a data center, pixie boot off of everything, and then it starts growing out the cluster. So it's really cool. So Helm, if you're not familiar with it, what is it? So there's a couple different aspects here. If you are a Helm developer, right, you're really thinking about the lifecycle things. Like, so you're going to put it with an apt or a yum or something like that, because you can do things like installs, upgrades, rollbacks, etc. Right? So it has this component of managing the chart lifecycle and so forth. Right? I don't really think of it as much of that. There's those aspects which I would expect for anything that you're gonna, manage, manage your manifest with. But really, it's the templating piece that's the key. The templating piece is the piece that gets it improves with each iteration, right? From V1 to V2 to V3. That's the really important part. That's the powerful part. That's where, Tiller comes in. You've got this rendering piece, and then you've got this piece that actually does the deployments. So, we'll kind of go through this a little bit. So it's really all these things. Like if you look at the templates, you look at, the helpers file and things like that, there's some mustachious things in there. It has some roots in Golang, so it feels a little bit Golang-ish. And the main thing is that it has lifecycle management of your Kubernetes deployments, and it is a template rendering engine, really, at the end of the day. So the chart structure is like this. If you're familiar with Helm, you're familiar with the chart structure. So essentially you have, it's pretty simple. You've got your main chart that's defined. You've got your README, chart YAML, values, and requirements. The README, self-explanatory. The chart basically describes your app versions and things like that. So that's how you would version the chart. Your values are the essentially like variable overrides, or it's an overrides file. Your requirements is what would pull in other charts. So Helm has this concept where, bad example, but if you've got a WordPress that needs a database, you would put that in your requirements and it would go and fetch the database. The problem with that, and this is an issue that we had at AT&T and Charter, is that you don't want several copies of a database just because you want to roll out several instances of things that can talk to a single database. What you want is separate databases within that thing. So how would you manage that? How do you pull all this together, right? If you define them in the requirements file, then you're going to deploy several iterations of the same thing, and that's kind of a waste of resources. So there's another way to do that, and we'll talk about that. So the values, again, this maps up into basically like key value pairs for these overrides that you end up using, and we'll kind of go more in depth when we talk about libraries. So this is a really messy slide, and I need to go back and change this a little bit, but this kind of tells the story and why we're here. So if you're familiar with Helm and you're familiar with some of the, I would say, security concerns with Tiller, it's mainly because of the history of what happened in this, place and time. So for instance, Kubernetes was V1 in July 11th of 2015. There was, mostly the Kubernetes community was just trying to grow a little bit. There was more growth within the community. But then once people started using it for real workloads, right, outside of just a nascent lab and developers and things like that, security teams are getting more aware. You kind of hit this 2017 phase. And in 2017, I don't know if you guys, how many of you have been using Kubernetes since like 2016, 2017? Okay. So around that time, there was a lot of security awareness within the Kubernetes community, and it was extremely disruptive. And so if you want to know what it's like to manage an open source project that is trying to keep up with Kubernetes, then this is your story essentially here. Around the March, June, August timeframe, that's when the things like RBAC came into play. That's when TLS came into play. So every other project had to respond to that. And then the cadence within Kubernetes is a new release every month, and then you've got a new major release every quarter, right? So that's really hard to keep up with. I don't know how many of you guys within your organizations do a new release every month, a new major, okay. That's usually a pretty well-oiled machine within an organization that can do that. Otherwise, it's really kind of tough. And in an open source project, I think they've done a great job of managing that. But that's not to say that every other open source project can deal with that type of, that rate, right? So anyways, Helm was kind of left with, addressing these security things. And then if you remember back in time, the Helm team was really the Deis team. Deis team got acquired. So I think they got acquired like somewhere around end of 2017 or something like that. So Microsoft got them. So they had this thing called Tiller out there, and Tiller has some issues. And so it's not that the Helm team didn't know that some issues were there, but the thing is, it's really up to the people that are implementing Helm to understand what you're deploying. It's not really up to the Helm team to say, you know, hey, it's hard to make things secure by default, but that's how it should be. But in essence, there's a certain model that they want you to deploy in, and they've stated that several times. So we'll go over that a little bit. Any questions? It's a messy slide. We're going to clean it up. So this is where we're going to talk about Tiller. I've mentioned it a few times, and now it's time to kind of lift the covers here. So initially, the way that it works is you've got a client side and you've got the server side. The client side that's in charge of all the rendering, right? So if you've got to do rendering and you want to do like, let's say a Helm template, you're not really calling Tiller when you do a Helm template. You're essentially saying, okay, take these values and then override, you know, you want to essentially render the chart, right? So the client is in charge of that, but in order to talk inside the Kubernetes cluster, it's got to make a call to the Kubernetes cluster and say, okay, I need you to deploy Tiller, this thing Tiller. Now what Tiller does is it manages the lifecycle of the charts themselves within the cluster, right? So typically, I'm gonna take a scenario like for us. Let's say that Tigera wants to make use of a Helm chart to deploy a CNI. We couldn't really do that until some of the later releases of Kubernetes. I think it was like 1.13 or 1.14 where you could taint the node a specific way or whatever and say, you know what, run this on a node port and then regardless, just deploy the application anyways, right? So you could do that with Tiller. But then Tiller is running on a node port and that's a problem, and then we'll kind of address that. So what happens is when Tiller gets launched into the cluster, it's launched like any other workload. And then it starts to get deployed. And when it deploys, it does two things. It opens up a REST call to the Kubernetes API using the credentials of whoever launched the Tiller service, right? So let's say, and this happens a lot, I see a lot of people, I mean, tons of people. And I always ask, like, how do you deploy Tiller? And they're like, well, you know, just kubectl and, you know, either deploy a manifest. We got people that do that. They'll deploy Tiller to a specific namespace. Or what they'll do is they'll just use Helm to deploy it. That's the primary thing that I see. And they typically do that with the cluster role admin access, right? So what then? And that's where we have some issues. So what ends up happening, let's say we take that default, we just do a Helm init and then Tiller gets deployed. What ends up happening is if we make no other changes, we got this port on the inside of the cluster on a kube system network namespace on port 44134. Now, if you know much about network services inside a Kubernetes cluster, you can still access all the services within the cluster, right? So, I mean, you know, unless you start using network policy, I can hit 44134 inside that cluster, no problem, right? So what happens when we do that? So continuing on, now that we have that REST connection to the Kubernetes API using the credentials of the person who launched the service, and we've got 44134 on the inside of the cluster listening for connections, what ends up happening is something interesting. So we set up a gRPC tunnel from the client to Tiller. And what ends up happening is we basically make a call to the Kubernetes API and we say, essentially do some funny stuff. Let's proxy so we can actually get to the service inside the cluster. So it does a proxy back to the client. And then we have our gRPC established connection, right? So that's how Tiller, that's how the client talks to Tiller. Now I'm assuming we did TLS there, right? But most people don't use TLS. So essentially you've opened up a hole inside your Kubernetes cluster on the kube system namespace. You see where I'm going with this. And you're not using it over TLS and you're sending your charts over there. That includes secrets, folks, right? So I can sniff that wire and get everything you're sending. So are you yeah, okay. So anyways, that's where we get the funny business of the port forward. So let's say there's no issues and we continue on, we deploy a service using Tiller, right? So what ends up happening is the client says, all right, open up a kube proxy connection, send a chart out to Tiller. Tiller goes out and deploys a chart. So we've got a BAS chart, and we've got some other charts in there as well. No problem. And then what we do is we use the regular kubectl commands to manage those services, or at least look at those services, and hopefully we're using Helm to manage them. So getting back to the 44134, Tiller has no auth mechanism whatsoever. So the auth mechanism is handed off to the Kubernetes API. So what does that do? Well, since there's no authentication there, that means that, and we established that this is a cluster role admin access, right? Any service inside the cluster can now deploy any other service, including elevating the privileges of a workload within a different namespace. So now you can start taking over the host entirely. The demo is going to be this. So we'll show you how this works. And it's like so ridiculously easy. I've got a container that basically tells you what commands to enter to take over a host. So anyways, what happens in this case, we've got, let's say we do like a cross-site, scripting exploit. That happens all the time. We've got an API. Did I lose this guy? Is this still? Okay. So let's say that it's an API and we did like, a cross-site script exploit on this workload, take over the workload, no problem. Now we're inside the workload and we're issuing commands to then elevate our privileges. And now we can take over the whole host and everything just starts falling from that point on. Any questions? So Tiller's an issue in V2. Now the response to that from the Helm team would be, and this is totally true, you shouldn't deploy this just doing a Helm init with cluster role admin access. I mean, that's what you shouldn't be doing. And you shouldn't really be deploying services with cluster role admin anyways. These are typically the same teams that allow root access onto a server. So they'll give you a server and say, here you go, there's root, and not use sudo. So like, it basically just exposes a practice inside our organizations because we haven't been keeping up with best security practices. That's it. It's not any fault of anybody's, but then you take the history and everybody knows that we want to go back and change the things in Helm v2 because we've learned some things. We could use the Kubernetes API to do everything. And that's basically the Helm v3 model, right? So we'll get back to this in a demo. So just kind of keep that in the back of your mind, but we've basically owned this node. So what you'll see is your security researchers and your security teams and things like that, if they're a good security team like they should be finding my stuff out on the internet, right? Talking about this. And I got this from somebody else. So like there's people talking about this, but essentially what you're doing is you're kind of opening up, if you're a development team or you're a sysadmin or something like that, you're kind of opening yourself up for the security team scrutiny that's going to come your way. Because they're going to say, okay, what's Tiller? Okay, you guys all love gRPC. I think gRPC is amazing. It's great for a developer, but like on the firewall side, it kind of really irritates people like traditional firewall folks, right? And then there's no identity, so there's no concept of a least privileged model within Tiller or anything like that. So like, this is the stuff that developers and sysadmins, we don't want to deal with, right? So we just kind of want the things to change. So it basically boils down to this, since there was so much focus on Kubernetes security a while back, Kubernetes already has a good framework for least privileges. So let's just like use that. That's the V3 model, right? So some of the security enhancements in Helm v3 is that there is no more Tiller. You don't need Tiller. You can use a combination of, CRDs. They talked about CRDs. We'll kind of go through what you can actually find in Helm v3 today. And actually my release is just a release or two old, but Tiller is no more. It doesn't need to be there. We can leverage everything that Kubernetes provides. So basically, if you have a least privileged model already in place, and you're using namespaces, because people do use namespaces, right? And a lot of people then take that a step further and tie a service account to a namespace. Do you guys all do that? Okay, yeah. So Helm, if they're using just all the core Kubernetes concepts or whatnot, then you can just have Helm leverage all of that and not have to worry about Tiller at all. And that's great. So that's the case. So any type of authentication that you would typically set up in your kube config file or something like that, that's what Helm v3 would use, which is an awesome model. Any questions so far? Okay. Is everybody following along pretty well? Okay, cool. Helm folks for sure. All right, so yeah, that also means that we're using the same TLS connections that the kube, the kube client would use. And then all your audit records are now recorded at the cluster or federated level. So for instance, if you're leveraging Kubernetes for all of the authentication piece, you're leveraging it for all the logs, you're leveraging it for everything. So if you manage that, if you start implementing like, you know, a federated model within Kubernetes, then you've got your audit trails for that, et cetera. So now we talked about, that was some of the security enhancements. I did say that this would break down into 3 kind of categories, main categories of improvements. The operational improvements, and these are somewhat experimental. So some of these features I found were defined in, you know, I would say the plans from the Helm community, but not everything has been implemented. Most things are being ported over right now, right? Just for functionality and so forth, and feature parity between V2 and V3. But what's really cool, I think, is now you'll be able to push and pull charts straight by the Helm client, right? So there's a couple things. I don't know if you guys have heard of auras. Is anybody familiar with auras? Auras is really cool. I definitely suggest you check it out. So it basically uses an OCI compliant registry to push and pull files of any type, right? So text file, your tar files. Tar files, we already knew that works because that's what a Docker image is anyways, right? So you can push and pull charts. So basically auras will allow you to push and pull charts straight from the Helm command line. And that's really cool from an operational perspective. So you can actually do this. You can enable some of these features by exporting the Helm experimental OCI = 1, just turning that dip switch on. Also, plugins can be customized for specific spec or protocols. So example, you can have a plugin for Helm v3 that, you know, takes advantage of like S3 buckets and things like that. And so because you're pushing and pulling charts or whatnot, it uses the same type of like Docker login, so you can do a Helm login. I've been testing that, it works really well too. So definitely check that out in V3. Now, some additional things too. They've talked about a release object in the form of a CRD and matching secret. So if you've ever looked at what gets deployed by Helm, it's essentially a config map that then does a base 64 encoding of the entire chart, right? So the chart file itself. That's no different than a secret, really. So they ended up using a secret. So I'll show you a Helm v3 command line, and you'll see the secret. But it looks like it's still just doing a base 64 encoded of the entire chart. Looks to be the same thing to me. So the secrets now represent a version of an application instance. So for instance, in Helm v2, you would have like a release enumeration of 1, 2, 3, 4, 5, etc. But what they've done now is they actually use like a ULID. So you have a unique identifier for the Helm release at this point. And then you can use the Kubernetes API to fill out what releases are there. However you're doing that today, you can do that the same way. Now, the biggest thing is that you have namespaced artifacts by default, right? So since there is no tiller and you're using all the RBAC controls and everything that's available in the kubeconfig file and within RBAC, et cetera, now all the deployments are namespace as well. So if you want to deploy something in the kube system namespace and you're an admin, no problem. You'll see all the deployments in the kube system namespace, but that's separate from, let's say, you know, Calico monitoring namespace or something like that, what have you. That's really nice. So like, for instance, the deployments, the secrets, et cetera, that would all be corresponding to the team that would manage that namespace or control that namespace. So pretty cool stuff. Any questions? Okay, so that's all available today. Some things that are planned, which I haven't seen the code actually come out yet, but they have described this, is Helm controller. So Helm controller is really cool for your folks in CI/CD, you know, the folks that are controlling your CI/CD mechanisms. So what that is essentially a subset of the commands that you would use in Helm. So for instance, you know, Helm would have like a template, you know, things that would help developers and admins and things like that kind of manage these charts. But if you're using it in CI/CD, you only have a few things that you really need to do. You need to install, you need to delete, maybe purge things, et cetera. You need to do an upgrade, et cetera. Some of the control mechanisms, you may want to do that. So the controller is going to be a separate project outside, so they can leave Helm core-ish, I would say. And then the controller will be a separate project that you can use within your CI/CD workflows. So that's pretty cool, actually. And then there would be more granular RBAC restrictions that you can use with that as well, or you can get more granular with it. Now on the development side, this is really cool is, how many of you guys have used Lua before? For gaming or Nginx or gaming? Yeah, there you go, World of Warcraft. That's like, there's always one, for sure. So anyways, if you're familiar with Lua, you know that it's a really powerful scripting language, essentially, right? So it's got kind of the power of C. So you can use this to manage several aspects. There's like a new extensions folder, and you would put your Lua in there. And I'll kind of show you the architecture and where that ends up. So it would live in the extensions folder. So, and then also, there is no more requirements. So if you have dependencies for your charts and things like that, that gets defined in one place now, which is chart.yaml, not in your requirements.yaml. So that is no more. And then on the development phase, some other things too is, we talked about this. They did consider some other things, Python, Ruby, etc. Lua kind of won out. Lua is pretty awesome. Like if you haven't used it, you should check it out. It's really easy to learn. It's really powerful. You got a lot of power in Lua. So I'm really happy that they went with Lua in this case. Some other improvements that are planned, they're not actually available yet, I don't think. So if you have a lot of charts and you end up hosting a lot of charts in a chart repository, let's say 100, 300, 400 charts, etc. Your flat index.yaml gets kind of difficult to read and index out, right? So what they did is they're going to go to a JSON model, and the JSON model is going to have a tier structure, right? So you'll have a top tier of each of the charts, and then within each of the chart tiers, then you'll have the versions under that, right? So it makes it a lot more readable, machine readable, a lot faster, etc. So YAML just takes a lot of like processing power to go through a chunk through a huge YAML file. So that's an improvement. And then you don't need that Helm reset, Helm serve, etc., because there's no server piece in it anymore. And then when I was talking with the Helm developers, they strongly considered that, or they strongly said, hey, kind of look at the chart museum pattern for how we're going to implement like a plugin for chart museum, etc. There's one out there. It's really cool. So anyways, what does this look like now? We kind of saw the old. So the new kind of looks like this. So we're using secrets. We'll show you how that looks within the command line in one instance. But then you have a secret that has your release and release version, etc. So it's a lot more simplified. There is no tiller, so you're not doing any gRPC anymore. You're not doing any kube proxy, so you don't have to worry about wrapping, the tiller protocol, over TLS anymore. It's a lot easier to manage. So platform folks, security folks, it's like a win for everybody, really. So, but the chart structure itself gets a little bit more complicated. There's more to know. And I haven't met a person that says, oh yeah, like I totally want to jam out and like write some Helm charts today, right? I mean, they're painful to write, honestly, but I'm going to show you how to kind of write them a little bit, I think a little easier. So we're all just kind of sharing information with one another. That's what these meetups are all about. So I'll kind of show you what we did to reduce some of the workload at AT&T. It's complicated, but for some of the advanced users and things, I think it's like the way to go if you don't want to write charts all day, right? So a lot of people have kind of looked at other alternatives now, like, what's that? Like Customize, that's the top one. People are looking at Customize. I think they can somewhat work together in ways, but a lot of people, it's just like a straight up competition. So, but the structure, now you've got like a library folder, an extensions folder, which is where the Lua scripts would go. Pretty much everything else on the right-hand side is going to be about the same, right? So they've added some additional functionality. So that's it. So we'll go through the demos. Any questions? All right, cool. So let's get set up here. Shut this off while we do this. And then we're back on. Okay, cool. I feel a lot more comfortable sitting down here. All right, cool. So what we're going to show you, let me make this a little bit bigger. Make this a little bit bigger. Okay. So I try to make demos really super easy. What's that? Yeah, sure. Sure can. My microphone's falling down too. Stay. Okay. Is it? Okay, so folks in the back can kind of see? Okay, all right. So what we're gonna do, I'm gonna give you a repo at the end of this too. You can take a screenshot or I can give it to the meetup organizers. This is really easy. So what we do is, and by the way, I did not really come up with this. I, just like everybody else, I read some things out there, found some stuff that I thought was alarming. All I did was simplify it in the demo because I hate typing in front of people, right? I mean, nobody likes to type up in a demo. So basically what we're gonna do is we're gonna run an image here and super easy. So there's gonna be some demo scripts in here. And so if you just do a demo, there's like 7 of them, right? And I actually tell you what each one's doing. So in this case, what we're doing is we're trying to look at the Helm version. So let me tell you what's in here. We used Helm, here, I'll kind of show you something first. So if I do a Helm list, we have a Helm chart that's been deployed, all right? Now in this case, I'm saying, all right, I wanna deploy my CNI with this. And that's kind of difficult. We have to do some things in this case. So we have to run it on a node port. So I have 44134 exposed on a node port. But just to be clear, it doesn't have to be on a node port for this to work. 44134 is exposed in the cluster anyways. So you can get to 44134. So anybody that has a workload inside the cluster, you can do the exact same thing. And I'll give you the repo where you can test this for yourself. But anyways, what we end up doing is we run this image. And what we're trying to do is just feel out what's in the cluster. That's what a security person would, like if you're a hacker, that's all you're doing. You're just kind of laying in wait and just doing a feel of what your environment. You're just trying to feel what's out there. So the first thing that we do is we try and look for something by doing a Helm version, right? Let's just see if Helm is here. We know Helm is here because we found the binary, but we want to see what that's talking to. And we're actually looking at it from within the cluster. So how can we discover things inside the cluster? DNS. So we just start using DNS to look for Tiller, right? So we know that Tiller should be somewhere. And so what we did was we felt out, okay, let's see if we can telnet to something named Tiller-deploy, which is the default name on the kube system namespace, which is where I see people deploying it all the time. So stop doing that. But anyways, what we're gonna do is, once we get out of this, we'll just go through this. So 3, what we end up doing is we want to get the version now to see if like we're actually able to talk to the cluster. We know that the port is available, but can we now start talking to Tiller and get something back from Tiller? And this is bad. Like we can see now that Tiller is responding perfectly fine. So what we're gonna do is we're gonna get the secrets. Can't get the secrets. Why is that? Does anybody know why? We're in a default namespace. So we're not in the kube system namespace. So if you want to prevent someone from going from one namespace to another namespace, what would you do? Yeah, you would have some access controls in there, right? So what we're going to do is break down the access controls. So what I'm essentially walking you through is, okay, we know that Tiller is there, but we can't access it by, you know, we don't even know where it lives, what IP address, et cetera. But we've got this cool thing called DNS, which is going to tell us everything about the cluster. We can find everything in there. But what we want to do now is we want to get some secrets to see, okay, do we have the authentication and authorization to get in something in that namespace? And we don't. So what we're going to do now is we'll just launch our own chart, no problem. And what we're going to do is we're going to elevate our privileges in the workload, right? So now we have the correct authentication and authorization to get the kube system. So what are we going to do next? We're going to try those secrets again. Uh-oh, that's a problem. So If you have 44134 in your cluster, shut it off now. Like, I don't know what you guys are doing with it, but you don't even need it. So here's the cool thing about Helm, right? The only time you need like 44134 is in these obscure cases where a workload needs to talk to Tiller. And like one of those cases would be Chart Museum, right? Because Chart Museum obviously needs it, right? But your other workload shouldn't need to talk to that port. And there's a way to shut that down, and we'll kind of go through that. So what I want to do now is I want to see, can we get the secret now? Since we can see all the secrets, we already know what the answer is. But I want to see what the original deployed token was for this kubeADM cluster, right? Maybe I can learn something about, you know, about this, about the person who set this up. So Tigera secure 24EE. That doesn't look very secure. So you can get anything, right? And all we're doing is we're pulling the secret. We're doing a base 64 decode on the secret. Secrets aren't that secure anyways. You should be using secrets management, especially if you're in banking or anything like that. Like I said, the containers out there, the charts out there, run this at home. It's all good. Just don't run out of work. I wouldn't recommend doing that. So what we're gonna do is now, how many of you are actually using Kubernetes network policies today? Or Calico network policies, even better? Now, I'm just talking open source, right? I'm not selling you a thing up here. I'm just a dude on a stage. Not even a stage. I'm not even up. I'm just like eye level. So what we're gonna do is we're going to use a Calico policy. And like I said, I should have just reversed on that. Second. Okay, so we'll apply a Calico policy. If y'all want to see what that policy looks like, let's just do this. It's really, really simple. You guys should all know Calico policies, but what makes them kind of cool is that you can do an ordering, right? So you can do advanced ordering in your policies. You can do accept, deny, log. So you can have like a log ordered network policy right above a deny policy, so you can actually see what's being logged before it gets denied, right? So you can do all this with ordering. So that's where the ordering comes in. Now the thing about your network policies too is that you can apply your policies in, let's say, a whitelist model. So you can have, like, let's say a Fiodo, you know, network feed that's coming from known bad actors, right? And you can update the network feed nightly with like a cron job, right? So what you would end up doing is you would pull that network feed in, and then you say, okay, we're gonna label this network feed something and say, I wanna block this network feed. And so what you're essentially doing is you're kind of creating a sandbox for people to safely deploy applications, because you're kind of deploying, you're deploying policies in a block mode, right? You know things can be blocked. And then you whitelist everything else. And then what you do is you use the ordering to place them correctly. So you're blocking the things that you want to block up towards the top. You're allowing the applications towards the bottom, and then you have a deny rule at the bottom, right? So what we're doing is we're using these selectors are going to be your labels. So I'm looking for anything that's app equals Helm or name equals Tiller, and I'm applying a policy of deny in this case from any network on this port 44134. So now that we have this policy in place, any questions there? That's pretty easy, like self-explanatory. Network policies are nothing to fear. Like once you start using them, I mean, it could save a hack. So, you know, that's always a good thing. So what we're gonna do is we're gonna run this again, and we're gonna do the same thing. So we know we can access it, or we accessed it before by DNS. So we're gonna go straight to that one. And yeah, I can't get there. So it's blocked. 44134 is gone. Do you guys know why Tiller still works? It totally works. Like I can still deploy an app, no problem with Tiller, because of the gRPC tunnel. So now you just have to worry about wrapping TLS around the gRPC port, and you're good. That's it. Because Tiller in V2 is always going to use gRPC from the client to the host. The only time you don't need a gRPC tunnel is when you're inside the cluster and you want to talk to Tiller directly. and launch a workload. That's the only time you want to use 44134. If you're not doing that, then you can use the client that will initiate the gRPC tunnel. Yep.
I feel like I missed something. If it's gonna use gRPC, just go over HTTP, then why does it need
44134? You don't. That's the, yep. You should have seen the folks in Austin. They were like, are you kidding me? Like everybody was using Helm. And nobody knew this. That's why I'm here. Having fun with you guys tonight. So it's good weather. I just wish we had more people, right? So anyways, so did we learn anything? Okay. All right, cool. So Helm v3 solves all this, just to be clear, right? It's awesome. Like I've been using it pretty much exclusively. There's some little things, but there are things that just need to be ported from v2 to v3, like easy stuff, really. I even told them I would port something over soon, like when I get some time, but time's been really challenging lately. So I've been kind of doing the roadshow with this lately. So people are interested in Helm v3. It's awesome. It's really, really cool. Yeah.
As a proponent of Helm, how would you compare it to customize? Like I know, like I would consider Helm better for like distribution.
Mm-hmm.
Like if I take the pain to like write a chart, then it's really easy.
Yeah.
But then, so like, how would you, like, is it gonna get close to like what customize is for just like my internal management of a customization or a chart or whatever?
So tell people how you use customize first. Like, I think that's a good conversation.
Sure. So I'm sorry.
It's all right.
Just like for template, it's same thing as Helm, just templating my own stuff, but I don't end up like making a chart and then like I'll just store it in my own repo,
Mm-hmm.
and then I don't need to like share it out.
Yeah, you're basically doing a patch method, right? Customize is a patch thing. And to be clear, customize, like the actual customize bits and pieces are in the Helm, are in the like kubectl client, right? So like you'll see that popping up in there too. I don't know if you knew that. It's in 115, I think, or something like that. 114, 115. So I personally love Helm. I do. Like, we built huge things off of Helm. So like a charter, for instance, they're so in that we were using Helm to actually deploy the Kubernetes services themselves. So like the API, the scheduler, controller, all that was a Helm chart. And so what we would do is we would use the concepts of Kubernetes plugins, like the plugins folder, to bootstrap a self bootstrap cluster, right? And then we would deploy a chart, so that way we had a deploy artifact, right? So if you're heavily operations driven like that, I would say one of the benefits of Helm, right, is there's a clear demarcation point between the operations team and what they manage and the development teams. That's a clear line. For things that, like for businesses that I worked at, that makes a lot of sense, right? Telcos are very structured. You have, this security team, this operations team, there's a lot of throwing over the fence kind of thing. That's just like 100-year-old telephone company. The same thing was at Charter. It was even worse, actually. So banking is like that too, right? Banking is very siloed. You have developers. They're not going to deploy things into production, period. That's, would you disagree or would you agree? Anybody banking in here? Okay, all right. So in a case where you need that demarcation, like the world can't be run just with devs yet, right? So there's a whole lot of other components in a company and you have to look at it from your org. I can't tell you what to use. I try and stay away from those battles entirely. I personally like Helm because of the demarcation between the two teams. Yep. Any other questions? Yeah. It's vague right now. The developers are probably the best place to ask, or the best folks to ask. It would be lower level routines that can't be handled by the Kubernetes API. Think of it that way, right? That's where I see Lua fitting. It's probably best to get an answer from them. I have not seen any examples. Like, and I've been asking him, you know, like Matt Fisher, I've been asking Matt Fisher, hey, you know, kind of bugging the team a little bit, like a couple months ago when I started the talk. Okay, yeah, tell me about the plan on this. Tell me about the library chart, because I'm like huge library chart fan. I'll show you guys how that works. But that was one area where they knew they needed something else to outside of the Kubernetes API to handle these low-level instructions. You know, maybe that would be, you want to manage how things come up outside the Kubernetes API. Maybe that would be a good use case. But
things like plugging into more traditional like DNS and load balancing systems on premise where they got all interface and you don't have control over there. You can do a call out to say configure my VIP on a load balancer and register this IP or register this name in DNS, then deploy this ingress controller.
that's right. Yeah. That's exactly how I understood it. It's a better answer though. Yep. You had a question too?
Yeah, I may have missed this, but with Helm v3 using secrets,
Mhm.
we'll get shoved. Is it just the vendor chart? It's all shoved into a secret?
Great question. Yeah, so let me show you here. After making it much bigger. So what you have here is the secrets, right? So there is my chart, right? So you still, at this point, I think this is just an artifact of it getting ported over. And this was, they had one other alpha release and now they're in the beta release phase. So I think this is Helm, it's Helm v3 beta 2 possibly that I had here. So I need to look and see what code changes have happened. Like I said, most of the things are just getting ported over. But if you were to, let's say, do a describe on this. What you'll start seeing though is that, let's see here, actually, what I wanted to do, that was not what I wanted to do. 1 second. That's why I hate typing these things. So that's essentially your secret. If you end up doing an edit of this, what you'll see is it looks exactly like the V1 model or the V2 model, where it's base 64 encoded, you know, value of the entire chart itself. Yep. Yep. So, and to be clear, we did this at Charter too. So we had like, we used Helm, and we used Helm really kind of as a Go library essentially, but we had a higher abstraction basically that did the, remember I told you like, you know, if you have a terrible example WordPress and you need a database, you don't want several copies of that. How would you end up reusing one database and just putting separate, have separate like table structures or whatever for different deployments, right? So what we ended up doing was we built a higher construct using all the Helm things. But what that does is it lets you piece everything together. AT&T has something similar. It's called Armada. You can check that out. Ours was called Barrelman. It's just a Golang version of that. But what that does is it essentially does the same thing. We manage releases. We went to secrets a while ago. But then we would have our actual deployment of several components, right? So like, let's say I want, let's say I have like a 10 microservices or whatever for one application, okay? And then what we did was we created an artifact around that whole thing, and then that was a release and a secret, right? So we manage secrets a little bit differently. It's nice to see Helm is doing this as well. So I got about 5 minutes. I want to show you one concept, which would be a library chart. Did that help answer a little bit what it looks like? Okay, cool. So I'll try to make this a little bit bigger. But what I'll show you is what a library looks like, at least from what I'm familiar with, right? So I've got what's called a Kubernetes common library that gets called in this case. And what this does is it's a combination of utilities and snippets. The utilities are basically things to do like a map and reduce and, your typical like programming things that you would need to just manage, chunks of YAML or whatever and break things down, et cetera. So, but one thing that you could do is, let's say you want to look at, let's say you want a chart to automatically figure out if it's going to be V1 beta 1 or a V1 beta 2 or an apps V1 or an extensions or whatever. What we ended up doing was we wrote a helper file, and then we take this definition and use that in every single one of our charts, right? So we don't have to worry about what version like it is, right? All we have to do is go back to our helper file, and then all the thousands of charts that we have, hundreds, honestly, all the hundreds of charts that we had would have this, and all we needed to do was update it in one place, right? That's a lot easier to ask your dev team to do than to, use VI and find every occurrence of, your extensions, V1 or whatever. That's like crazy. So use that concept for other Kubernetes-ish things, right? So for one, here's another example. This is out there too, by the way. I will give this all to you and you can pass this on to the team. But like one would be a snippet, and we have a way to manage the metadata stuff. I think it might be in utils. Nope. It is in snippets. Okay, yeah, metadata labels. So the way that this works is you would, let's say, you can put in a values file what every single deployment should have. So example would be like, I always want the date of every deployment, right? So that way we can know when we need to upgrade things, refresh things, et cetera. But maybe, as an example, maybe we want to, I think I have this here. Yeah, okay. So maybe we want to include a Jira ticket with it all the time. Or maybe we want to add labels on the fly, like to the all the components that chart manages. All we have to do is change one little thing, which is set labels.jira equals DevOps-1234. And then what we're going to have is this gets put into, I don't know if I did it right. This gets put as a label in every single artifact that Helm chart deployed. And it's because we have a Kubernetes helper file in a library that all the charts are calling as a definition, right? So if you're Helm, you know what I'm talking about probably. And if you're not, come see me. I'll kind of explain this. But it simplifies things, especially since like on the Tigera side, Calico network policies, you want to push your policy via labels, right? So you want your label taxonomy to be perfect, right? So you want certain labels to be there all the time, but you don't want to have to edit the chart or even edit the values when you deploy the chart. You just want those things to be automatic. So we can put this in a CI/CD workflow, assign a variable to what Jira is feeding into the Jenkins platform or whatever you want to use. And then that Jira ticket gets automatically deployed with every single artifact that gets deployed to a Kubernetes cluster. Is anybody doing that? Would it be helpful? Awesome. Like, that's cool. That's the type of stuff that this chart is for. It's a library. So it's essentially something that doesn't get deployed, but it's a library of references that are Kubernetes-ish things that each of the charts can call and use and things like that. That's where I start really liking Helm a lot more, right? It simplifies the development process a little bit. And then you have the clear, you can continue having those silos, right? Because there's silos in a lot of organizations. So I think that's all the time that I have. Sorry, I was a little bit late. I mean, if you can get here during rush hour with the game going on down, you can manage Kubernetes. Like, that's nothing. So yeah, but getting here on time was a trick, and I'm really sorry for being late. But you're welcome to see me afterwards or whatever. It's nice meeting you guys.
All right, thanks for coming out, everybody. That's all we got tonight. We will probably be back here again next month. We do not have speakers completely set for next month. So if you have a talk or you're interested in pitching something, hit me up, contact me on Tech44 or over Meetup. Thanks for coming out. Oh, grab pizza on the way out. We have way too much food. Take full boxes. Don't be shy, seriously. You can take beers too if you're not scared of walking down the streets with them. All right, thanks everybody.